So greetings. My name is Zishan Kansuri. Hajima mashite watashi wa Zishan desu. Watashi wa Nihongo ga surusu shika hanasimasen. That's all the Japanese I know, so I will continue in English. Today I'm going to present vision foundation models for autonomous driving, or how self-supervised learning can be used to leverage large driving data to train robust and generalizable driving foundation models. I'm joining you from Denso Engineering Services Department in Germany. So let's begin. In this talk, I will motivate the foundation models, why they are required, and what does the term even mean. So for this, I will use a case study of ChatGPT, and then we will move on to applications of training such models in autonomous driving, their risks and opportunities. By the end of this talk, you will not have a technical understanding of how to train these models, but you will know the motivation behind them and why they are required. So let's begin with a case study of ChatGPT. I'm sure you have witnessed the extraordinary capabilities of ChatGPT. By January, it was the fastest growing consumer software application in history and even on the cover of Time magazine. It is extraordinary not just because it can have a conversation with us, but it also has these emerging capabilities such as it can compose music, it can translate and summarize text, it can generate business ideas, it can play games, it can write and debug computer programs, etc. But the model was not trained to do any of these things. The model was instead trained to do only one thing. Given an input, it was trained to predict the next word. And just by doing this on a large scale, it is able to perform so good. So here we can see the development of these models. If you look at the leftmost GPT, this was trained on around 10,000 computation. And this was able to do simple tasks, but as we are able to exponentially increase the computation, new capabilities emerge. Keep in mind that this graph is not linear, but exponential scale. So unexpected capabilities emerge with respect to scale. To summarize, foundation models are large models that are trained on vast amounts of data, and they have emerging capabilities as we increase the computation. So what if we train such foundation models for vision-based autonomous driving, and why should we do so? Similar to how language models have been trained, we can use a similar strategy for the video. So given some frames in time, we can use this as input to the model and predict the next frame. So a company has done just that, and they are now able to predict and control these models in very good sense. So just by changing go left, go right, the model is able to generate all these videos completely by itself. So one application is directly that this model is able to generate these videos, but the most important application I find is the model itself. So just by learning to predict the future, the model has a very good understanding of the world and can be used as a feature representative. So for example, the features which are generated by these models using this featured learning can further be used for downstream tasks in a transfer learning manner. And these downstream tasks can be anything that are required for autonomous driving perception, such as lane keeping, obstacle avoidance, parking assist, path following, 3D awareness, etc. And the best part is by learning this feature representation on a vast amount of data, the model is robust and generalizable on new scenarios and different lighting conditions, different locations, etc. Another application is auto labeling. So only here, only the first frame was labeled, and because the model can predict the future frames, the model was used as a feature representative to transfer these labels from one frame to the different frames. The features are so robust that one doesn't even need to label the first frames. There are techniques such as graph cuts, which can be used on the features to segment objects. This can be used for direct object segmentation without any human labeling. This can also be extended to videos, as shown before, by labeling completely the whole video in an auto labeling fashion. Another application is image search. Just as in Google, you can search by image. You give an input image and you get different images which are similar to that. This can be also used to retrieve similar images using the foundation models. Uh, we have seen this that the capabilities of ChatGPTs as such are such great that there are news articles saying that is Google's ran over, etc. Another application is the opposite of search. There is so much data available in autonomous driving that we would want to sample only the most interesting data. And by using foundation models, we can look at their features and do just that. This can be used to further allocate resources on the data that is important and not on everything that we record. Next, we would like to talk about the risks and opportunities of such models. This is still a new field. The video which you have seen from Wave, which is predicting the next frame, this has been only released like last month, a couple of days ago, weeks ago, actually. And so there is a lot of things which we do not know that we do not know. There is a lot of hype, and not many are thinking how this technology can be applied outside of the language modeling. So there is also a lot of opportunity in that case. There is not only one way of doing this foundation models, there are multiple ways, and this brings huge opportunity ahead. One problem of these models is a single failure point. So a lot of the resources go into the development of such models. For example, OpenAI spent $100 million just to train one model, the GPT-4. And it takes a lot of engineering. It is very risky if this model fails. But on the other hand, if this works, then it's also similarly rewarding. This was also showcased by the case of OpenAI and their GPT-4. And the computation is a very huge risk as well. So the best of these models are very computationally expensive to train. So for example, the GPT-4 was trained on 10 billion flops. These models do not have to be, we do not have to put these models into the car. So they can act as a teacher to train smaller models, and these smaller models can later be put into the car, for example. Or this can be used, as we've seen in the applications slide, this can be used to generate training data. It can be used in different applications as image search, as sampling important training data, to auto labeling, and so on. So even if these models cannot directly be put into the car because they are so large, they still have a lot of applications. So to summarize, the foundation models performance scales with respect to data and compute. Not only they perform better, but they also have emerging capabilities. In the plot above, you can see that for language models, these capabilities, for example, uh, uh, instruction following, calibration, etc. These emerging technologies emerge only with respect to scale. Self-supervised learning can be used to train on vast amounts of data. So the key of foundation models is the amount of data it's trained on, and just to make this possible, you can use self-supervised learning to not rely on computation on expensive human labels, and use this to train the data. Similar fashion how language models have been trained as seen here. So generic feature representation models have vast amounts of applications, as we've seen. For example, automatic labeling, generation of synthetic data, very high quality, using these models as feature representations for downstream tasks, image search, sampling of out-of-distribution data, etc. On the other hand, this is an uncharted territory. All of this is quite new, and especially outside of language modeling domain, and that means there is a huge risk in training such models. It requires a lot of computational expensive, but there is also huge opportunities here. With that, I would like to end my talk. If you have questions, please ask me, and I would like to ask you, what would you use these foundation models for your work for?
Yeah, thank you, Siri-san. Let's move on to the Q session, and let's start from panelists. Narioka-san, could you start your question?
Yeah, thank you, Teresa, about your presentation. It was a very interesting topic, and I think there is a huge potential. How can we leverage this foundation model for our product? And yeah, as a very huge and very open topic, I'd like to ask you that how can we start to verify that okay, that foundation model could be better, could bring something important for us. For example, we have already started that tried the auto labeling and image search, which are very nice features that we have for the production line. So
Yeah,
but we have some dedicated models for that. We have auto labeling model, which is a larger model than production one, which takes a little bit more time than the production, but it doesn't matter because it's an offline process,
yeah,
right?
exactly,
This is very important because it is annotation is quite expensive if you do that. So you can spend a lot of money, and that doesn't scale. And
exactly.
we're trying to develop the auto labeling model, which is dedicated to some other tasks like semantic segmentation, object detection, or whatever we have. But if you bring your foundation model to that field, what's happened?
That is exactly what I also mentioned in the applications. So, for example, if you remember, we talked about how these models can be used for auto labeling in this case. For example, completely labeling semantic segmentation with the model itself, just by looking at the features without having any human intervention. What can be done is using these models, we can generate such labels, and human only checks if these labels are correct and only corrects them. So by this, we are reducing the amount of money that goes into human labeling and also time and effort.
Yeah, that kind of what we are now are trying to do, and we have partially successfully um, able to do that with a non-foundation model. And if you do that with a foundation model, which takes a lot of data, and maybe the cost is maybe really expensive than a normal model, but what's a key feature that we cannot do with a dedicated model?
Okay, so I think I would also call this dedicated model, which you have also a foundation model. I think the only difference is the amount of data. So
Mm-hmm.
similar with respect to uh, with the GPT, with the language modeling we have seen, uh, there have been also smaller models, for example, GPT-1, GPT-2, which were only trained, which have only like 10,000 petaflops. But
Mm-hmm.
as you increase the scale, as we increase the amount of data and the computation which we put onto it, not only the performance is much better, but also we have new capabilities. So for example, uh, in language models, we have all these. Yeah, for example, this chart, you can see that the first models only are able to do simple labeling tasks. But then as we increase this, they are able to now also write music, for example, or generate business ideas or translate, for example, and so on.
Yeah, that is exactly my point. Maybe we don't want to play the system that can play music, right? So I found a very interesting blog by Mobile Eye. Maybe you might know that, but so they are claiming that okay, this large language model, the LLM, is too much, and it is like trying to kill a fly with a rocket, right? So you don't have to have a big model for your specific use cases.
Yeah.
Maybe they're true, but I'm not quite sure. But if you can show something important and which we cannot do with a non-foundation model, that's very good. And I'm just wondering, what's your proposal? How can you start to develop your foundation model to convince people, okay, we need it?
Okay.
What the initial step toward that?
Yeah, that's a very good question. I think there is no end point here. I think just keep on increasing the amount of computation increase. And as you said, Mobile said that, yeah, we are trying to kill a fly with his machine. This is true, but we also don't know if such a model, train such a model will bring new capabilities, which would be really worthwhile. So we will know this only by doing the research and trying to develop such a model, and only then we will able to know if that is true or not.
Yeah, and to know that, to figure out what is this new thing, so we need to think about what the initial step was, and like a POC or pilot study, feasibility study, whatever you call. So we have to make a first step towards that. And I'm just wondering, you have some proposal or ideas in your mind, or is there any project starting in DNA already or not?
Yes,
So,
so actually, maybe you have know already this Facebook's model Dino V2. Uh, so Dino V2 is also like a foundation model. They have used self-supervised learning to train on Instagram data. So this is from Facebook. And they have shown capabilities of these models on downstream tasks. So tasks which are completely the model was not trained on, for example, depth estimation. And we have used such a model out of the box without fine tuning it on our data for our tasks. And this has outperformed the internal model. So this showcases that even though this model has not even seen driving data, it has not seen DNA data, for example, it's still able to generalize and be robust and outperform internal models. So this is already a proof of concept for us to develop in this direction. Also, we have an internal project from it's partially funded by the German government to increase robustness and generalizability of general autonomous driving, vision-based autonomous driving, and we are deploying foundation models and uh, researching how this can be used for this use case.
cool. Yeah, thank you. I'm looking forward to the next result. Thank you so much.
Thank you.
Oh, thank you, Nariko-san. Okay, could you start your question, Asada-san?
This, あれマイクが。
Yes.
Yeah.
Can you hear me?
Yes, I can hear.
Okay. Thank you for talking about the very new and very advanced topic. These days, foundation models, especially ChatGPT, is very popular around the world. So I believe that some of the audience also have some interest about this kind of topic. Okay, let me clarify something. So are you or DNAE already trying to develop these kind of foundation model, or do you have any plan to begin with?
Yes, starting this year, we have a plan which is funded partially by the German government. It's a 3-year project called Startup. And the goal of this project is to increase robustness and generalizability of like autonomous driving perception. And we are trying to develop foundation models just for this use case. So the idea is that doing feature representation learning and self-supervised learning on a vast amounts of data, which include night, day, sunny weather, fog, snow, rain, etc. Doing this feature representation learning on that and using that model as a feature representation for downstream tasks, which will already improve our robustness and generalizability.
Interesting. So, as you mentioned, developing foundation model requires a huge computational resource, like hundreds or thousands of GPUs. So, is there a good idea to acquire those computational resource?
So currently we are not at that stage yet. We are only we are developing proof of concept. We are in the proof of concept phase. We are using data from public data sets and internal GPUs, but there's for scaling with respect to the compute, we can use cloud servers. For example, AWS has a service which they provide, can scale with large amounts of GPUs just to do the training, etc.
Okay. Today you mentioned a lot of topic like large language model and world model or the auto labeling using self-supervised learning. So which part are you interested in the most? Which model are you going to develop?
Yeah, for me, the most interesting is not the ability to generate, for example, very good looking videos like this. Although this is very interesting. For example, you can just tell the model to go left, go right, and so on, and the model will generate videos for you. For me, the most interesting part is the model itself. So because this model has seen a lot of data, it is already very robust feature representator. You can think of this as, for example, uh, old school feature representations like SIFT or ORB features. These were very good and robust and have been used in very different applications. So I would think the model also like a very good feature representator, and these features can be later used with transfer learning on different kinds of tasks, and it would be robust and generalizable.
Okay, yeah. This model is very interesting. So I saw the how can I say, the article on the web from Wave. So I'm the one also interested in this model. Yeah. So you may I ask that which do you think which application do you think is the suit for this model? Which application will be the use case?
Yeah, so as I said, it can be, for me, the most interesting part is not the downstream applications, but the model itself. So this model can be used for all kinds of tasks in depth estimation, semantic segmentation, in lane detection. So you can have a fixed backbone and have different heads on top of it. And these heads will predict different tasks, for example, and this backbone will be a foundation model, for example.
Wrong.
Susan, can you hear us? Oh. Can you hear me? Oh. Oh, sorry.
Sorry, did you hear us?
Ah, ダメだね。そうだね。
Now I could hear Nihara-san, but maybe the connection was
Yeah.
not good.
Yeah, maybe it's good. I can hear Asada-san's voice.
Yes, now I can hear you. So just to repeat,
okay.
For me, the most interesting part would be the model itself, and using, for example, one feature representative model, which is a backbone of a model. You can attach multiple heads for it, and each head would do one task. For example, one head for lane keeping, other head for depth estimation, other head for segmentation, lane detection, and so on. But the backbone itself, which would be trained with self-supervised learning, is a very good feature representative, and we can use foundation model as a backbone.
Okay, thank you. If there's another question, someone can ask.
Okay, thank you, Asada-san. Okay, let's move on to the audience question. Do you have any questions from audience? Could you raise your hands? Okay, maybe not. Do you have any question? Any more question, panelists?
I think Yoneji-san is raising his hand.
Oh, really? I can't watch that. Oh, yeah, Yoneji-san. Yeah, you can have a question.
Oh, no, I don't rise up.
Really?
Oh, sorry. In my screen, Yoneji-san is raising his hand. Sorry.
Yeah, I can see it.
By the way,
Does
you have a
any
question?
Yeah.
Okay, if there is no question, I can ask. No, this is not a question, just a comment. Can I?
Sure.
Okay. Actually, I am the one who is considering whether this kind of foundation model can be used for any system. So this was a very good opportunity to know the person who has similar thoughts. So let me have a chance to talk to you maybe next time. Yeah, thank you.
Thank you very much. It's also interesting to know that you guys are also interested in these topics. If you have any ideas on how to use this and any comments, please write us, and it would be a very good opportunity to work together. Thank you.
Yeah, thank you.
Thank you, Asada-san. Do you have any questions? You have almost 3 minutes. No? Okay.
If not, I can ask another question.
Okay.
Yeah, I think one of the big issue we have is we have a lot of sensor data, like different camera types in DNJP, and maybe you have a different type of camera, and the type is not unique. So we need to think about how to fulfill the gap between the different domains with the foundation model. And do you see the foundation model has a capability to the good domain adaptation in terms of the different type of the sensor data, and to try to handle these, try to leverage all kind of the data set using the single model? And what do you think about that point?
Yeah, that's a really good question. Actually, in the project startup, which we are currently working on, that is also one of the one of the work package. They also want us to be generalizable to different cameras and also their mounting positions and angles and so on. And I think this is a very good application for foundation models. We can train the models at because it uses self-supervised learning. We do not have to for example, use the camera intrinsics or extrinsics during training. We can use different camera mounting positions, different kinds of cameras. Actually, we are using various public datasets, Kitty, Cityscapes, ACDC, and so on. They have very different cameras, resolutions, and also aspect ratios. The field of view is different. Camera mounting positions are different. So by training such feature representation models, we would be able to generalize to very new camera positions, orientations, etc. So the generalization capability here would be much better than only training on one single camera. I think so.
Yeah, I think that's the one way we can convince people how the foundation model is beneficial for us, because we don't have to play a music by a system. We want to do something important for our AD keeper functions, right? And
yes, exactly.
This domain gaps between the different modalities or different camera types, mounting position, all these are very important for us. And if the foundation model can solve these issues, that is a
yes.
killer application, in my opinion.
Yeah, that's a really good point. So not only we are using foundation models, for example, for different camera positions, orientations, etc., but also for the conditions in the environment, for example, lighting conditions during the day and night in tunnels, etc. This models trained on very vast data would also be generalizable to these conditions, and also weather conditions like snow, rain, fog, etc. as well.
Right. Yeah. Thank you.
Thank you.
Okay. Yeah, it's the time. Yeah, thank you for your very interesting and advanced topics, Suri-san. Thank you very much.
You're welcome. Thank you. ありがとうございます。
ありがとうございます。